All right, so we'll go ahead and get started on the second problem here. If you could do the first one, 1.1, you should be able to do the second one, 1.2. Might be actually worth giving this one a try and then looking back to see how you did. Okay, so given two vectors, that is not big enough. Let's see if we can fix that. I can't. It's just really... Okay, so given vector B and vector C, find all that stuff, which I don't have time to highlight. I do, but I don't want to. Okay, so we'll start with A, which just says B plus C. Well, B is 1, 2, 3. And vector C is 3, 2, 1. Which is just, if we were to add this up, all we have to do here is we just say, well, 1 plus 3 is going to be our x component, plus 2 plus 3 is our y component, or your j component, depending on which unit vectors you want to use. And 3 plus 1 is our z component. So all we did was we took our 1 and our 3, which were in our x slot, and put it here. Our 2 and our 2, oops, that should be a 2. Our 2 and our 2 here, and our y slot, and then our z slot is the 3 and the 1. And if we add those up, we get 4x plus 4y plus 4z. And there you go. That's how you add those two vectors. Hopefully that part makes sense. Now for part B, part B says 5 times vector B minus 2 times vector C. Let me just readjust here. So we can work through this kind of how we did before. 5 times vector B, which is 1, 2, 3, minus 2 times vector C. And we can distribute the 5. So that's 5, 10, 15, minus 6, 4, 2. And just how we did in part A, we can say that's 5 minus 6 is x hat, plus 10 minus 4 is y hat, plus 15 minus 2 is z hat. And after we do the math, that's just negative x hat plus 6y plus 13z. Okay. C asks us to compute the dot product. So all we do here is we just take our like components. So our x component is 1 times 3 plus 2 times 2 plus 3 times 1. 1 times 3 is 3. 2 times 2 is 4. So let's see, what is that, 10? And this is the dot product, which is a scalar, not a vector. That's one of the difference between the cross product and the dot product. And in part D, they want us to find B cross C. Okay? Well, this is going to be the determinant of, we'll use our unit vectors at the top. And then it's just our x for B is 2, 3, 1. And then for C, it's backwards. So again, if you don't know how to compute the dot product or the cross product, I'd recommend checking out the lecture videos. If you look at the playlist Classical Mechanics that I have, hopefully it'll explain some of this stuff for you if you're not sure how to do it. So I'm going to go ahead and work through this. This will be 2 minus 6 x hat minus 1 minus 9 y hat plus 2 minus 6 z hat, which is minus 4 x hat plus 8 y hat minus 4 z hat. And that is how we calculate the cross product. Okay. Cool. All right, so that's problem 2 done. The first 2 were pretty easy. It will get a little more difficult as we go along, but knowing how to do these 2 basic ones should be important for us. So that's how you do it. Hopefully that helps. Make sure to check out my channel if you want to see the rest of the solutions to the book.